Assalamualaikum and a very good day. So now we are in the last subtopic for week 11. This is week 11 part 3 video. We'll cover matrix inverse. We go first to the concept of matrix inverse. A square matrix A, we call it as invertible or non-singular if there exists a square matrix B called an inverse of A. In this case means that matrix A is invertible if there exists A inverse such that AB equal to identity matrix and BA also equal to identity matrix. In this case, this B is also inverse of the matrix A. And then B is called an inverse of A, which is denoted as A -1, and A is called an inverse of B. An invertible matrix A has only one inverse, means that inverse is unique for all matrices and is denoted by A -1. So A inverse equal to identity matrix, and also A inverse multiplied with A matrix equal to identity matrix. When the determinant of A matrix equal to 0, A inverse does not exist, and in this case, A is called non-invertible or singular matrix. We go to the theorem properties of the inverse. If A and B are non-singular matrix, means that non-singular we have learned previously, it is invertible. In this case, AB, if you multiply matrix A and B, then you take inverse, it is equal to you multiply B inverse with A inverse. The inverse of the invertible matrix is also invertible, means that inverse of the invertible matrix is, in this case, if you take back the inverse for the inverse of the invertible matrix, it is also invertible. That is the answer for this equal to A matrix. It will back to the original of the matrix. Any non-zero scalar product of an invertible matrix is invertible, means that here, if any scalar k is multiplied by any matrix A and you take here inverse, it will equal to 1 over k. So this part, this k will become 1 over k times A inverse. First, we go to inverse 2 by 2 matrices. The definition of inverse 2 by 2 matrices is given by, if we have here A equal to A, B, C, D, the inverse of this matrix is denoted by A -1, A inverse, equal to 1 over determinant of A, this is determinant of A, times, we change the position D and A, so D, A here, and B and C, we put here negative value, means that we have elements D, negative B, negative C, and A. So we know that determinant of this A matrix is given by AD minus BC, means that this inverse of A equal to 1 over AD minus BC times D, negative B, negative C, A, where this one we also call it as adjoint A. A is invertible if and only if determinant of A, which is AD minus C minus BC, is not equal to 0. If this one equal to 0, we can see it is 1 over 0 here, which is undefined. So inverse does not exist for that case. We go class for this example 1. We have two matrices A and B here, which is dimension 2 by 2. And the question asks us to show that AB means that A multiplied by B and you take inverse equal to B inverse multiplied by A inverse. So now we want to show the properties of the matrix is working for these two matrices. Now we need to find first A inverse. It is given by formula 1 over determinant of A times adjoint A matrix, which is equal to 1 over AD minus BC. In our case, we have 1 times 4 minus 2 times 3 multiplied by 4, 1, -2, -3. This is adjoint A. And when we solve this one, we'll got the answer 1 over negative 2. 4, negative 2, negative 3, 1 means that the inverse of A matrix is given by negative 2, 1, 3 over 2 and also negative 1 over 2. Next, we find here the inverse of B matrix. In this case, it is 1 over determinant of matrix B times adjoint of B matrix, which is 1 over 2 times x minus 0 times negative 2 times adjoint B is given by 8, 2, 2, 0. So in this case, we have here 1 over 2 times 8 is 16 minus 0, so 1 over 16 times 8, 2, 0, 2. When we solve this one, we'll got the answer 1 over 2 and then 1 over 8 and then we have 0 here 1 over 8 as the inverse of the matrix. And now we have this A inverse and B inverse. And then we need to compute A multiplied by B. In this case, we have here 1, 2, 3, 4 multiplied by matrix 2, negative 2, 0, 8. So in this case, we'll have the answer 1 times 2 plus 2 times 0 and then 1 times negative 2 plus 2 times 8 and the next element is 3 times 2 plus 4 times 0 and the next element 3 times negative 2 plus 4 times 8, which is the answer is given by 2, 14, 6, 26. Next class, we need to find here A, B inverse. In this case, we need to find the inverse of the matrix AB that we computed previously, which is 1 over determinant of AB times adjoint AB. For this one, we know that it is 1 over determinant of 2 times 26 minus 14 times 6, which is multiplied by adjoint of AB is given by 26 to negative 14, negative 6. When we solve this one, we'll got here the answer negative 0.8125, 0.4375, 0.1875 and the last element is negative 0.0625. So we are not yet complete for this example. We need to show that this AB inverse equal to B inverse A inverse. Now we want to show that B inverse A inverse equal to this matrix. So for B inverse times A inverse equal to, based on previous solution, we have 1 over 2, 1 over 8, 0, 1 over 8 times A inverse is negative 2, 1, 3 over 2 times negative 1 over 2. When you multiply these two matrices, you will got the answer negative 0.8125 and this element is 0.4375, this one 0.1875 and this element is negative 0.0625. When we compare this B inverse A inverse with this solution, we got the same answer. So here we can conclude that A, B inverse equal to B inverse A inverse. Means that we show that these two matrices fulfill the properties of the inverse matrix. Now class, we go to inverse 3 by 3 matrices. The definition of this inverse of 3 by 3 matrices is given by, if you have this one as 3 by 3 matrix and the determinant of this 3 by 3 matrix is not equal to 0, then the inverse is exists, which is given by A inverse is 1 over determinant of this A matrix times adjoint A. What does it mean by adjoint A in this case? It is actually is cofactor transpose. So we have learned before this about cofactor. We take the transpose of the cofactor times 1 over determinant of the A matrix. We'll got here the inverse of A matrix for 3 by 3.